Okay, spanning tree pop quiz. You have two switches, right? 24 port switches, and you connect them together with a crossover cable, and you think, okay, it's great. Now I've got the two switches combined. Computers on both sides can reach each other, but I'm feeling a little creepy. I want to make sure that, if that cable goes down, we still have redundancy, so I'm going to add another connection there. What does spanning tree do? Well, spanning tree does what spanning tree does. It blocks the redundant link, right? It's going to put a block on it so that a loop doesn't happen. Broadcast storms don't happen in your network, which is spanning tree's job. So somebody may ask the question, is there a better way? That's what we're going to talk about here. EtherChannel in all its glory. Going to look at the protocol itself. Other vendors call this a lag port, which we'll talk about that too. And then talk about how we can use this. Well, I kind of blew the answer to this question with my opening, but let's get into the specifics. Do a good little spanning tree review here. How would spanning tree handle the above situation? Well, it's gonna block one of those ports, but how? Well, remember, spanning tree elects the root bridge. Let's just say that we have switch 2 and switch 1 over here, and switch 2 ended up being the root bridge of the network. And the switch 1, once it realizes there's a loop, now how does it do that? Well, it's going to send a BPDU out. Which is a multicast message that will end up being sent out all ports of the other switch, and it'll see its own BPDU, its own little election ballot, come back to itself on fast Ethernet 0/2, and also see it come back to itself right here. So it's going to be like, whoa, there's a loop in the network. I got to do some blocking. So the first thing it's going to do is I'm going to say, I'm going to find the best way to get to the root bridge, and then try and block the alternate paths, the non-best ways. Well, in this case, let's just say both of these are gigabit port. I'll just put 1 gigabit per second on there. So both of these are gigabit. It's going to say, well, the costs are equal, so I really don't have a best way to get to the root bridge. So the second thing it's going to do to try and break the tie is say, well, I'll pick the switch with the lowest bridge ID. And let's just say, remember the bridge ID 32,768 is the priority dot, and we'll just say, whoa, on here. And this guy is 32,768, a whole bunch of twos is his bridge ID. Well, I mean, again, now that the second tiebreaker is useful if you actually have a system like this, to where maybe the root bridge is up here, and it's going to say, well, okay, this bridge ID is lower than this one, so I'm going to go this route to reach the root bridge. But in this case, both paths result in the same bridge ID. This big bridge ID right here. So it's like, okay, the costs are the same, the bridge ID is the same. Now what do? The final tiebreaker is just block the higher port numbers. So it's going to say, okay, lower port numbers are preferred. Fast Ethernet 0/2 is going to get the block. Matter of fact, I put that X in the wrong place because spanning tree only blocks one side, and it's going to be the losing switch, essentially the higher bridge ID, that blocks his side. So the block is placed right here. This line is effectively disabled, and now we have one path. That's how spanning tree works. What's new? EtherChannel allows us to say, you know what? Instead of blocking the ports between the switches, can we bundle them together? To where now you might say, well, sure, but I mean, doesn't that cause a loop? Aren't we back to the same loop situation? Well, here's how it works. With EtherChannel, the switches no longer see these as individual links. They see them as one logical port. See what happens is when I bundle these guys together, it's going to see them as one interface. So for instance, when it sends a broadcast, it'll send it out this port bundle as one interface. Only one of those lines will actually send the broadcast. It's not going to send it out both of them, thus resulting in a loop. So everything is seen as one. Now you can actually bundle up to 8 connections together. I mean, I can have 8 individual cables. So what does that mean? That means if I have 1 gigabit per second lines, I can bundle 8 of them and get a theoretical 8 gigabit per second connection. Now, okay, why are you saying theoretical, Jeremy? Oh, here's why. Each one of these lines is one gigabit per second line, right? So each one of these switches has a gigabit per second between each. Now, the way that the load balancing works, the way that the load sharing, how about that, works with the EtherChannel connection is not perfect balancing. It's not like bit by bit over. I'm waving my hands in the way. Let me describe what is. There's a technology. Matter of fact, I think we will talk about it a little bit later. Just briefly, it's called multi-link PPP. right? What multi-link PPP does is allow you to bundle multiple WAN links into a single line. So for instance, let's say I had 3 or 4 T1 lines between router 1 and router 2. I can set those up for multi-link PPP, and what the routers will do is, let's say a packet comes in, let's just say it's a 1,000-byte packet for ease of math, that a switch is sending into the router that has to get to a server over here on the other side. Multi-link PPP will literally take that and break that exactly even, meaning let's say it's 1,000 bytes, so 250 bytes will go out this line, 250 there, 250 there, 250 there. So you get, I mean, you're really encompassing all those. If a T1 is 1.5 megabits per second, you're going to get 6 megabits per second. So literally, when this guy's transferring a file to here, and if the line is all his, nobody else is using it, he's going to see 6 megabits per second of throughput, because the routers themselves are taking the CPU hit to fragment the packets, to actually chop them up into smaller pieces so that they can get exactly equal load balancing over those lines. Not how EtherChannel works. EtherChannel does not... the switches just don't have the processor to do that. Switches are hardware based, and the ASICs, the application specific integrated circuitry, the programming of a switch, only can support EtherChannel, which just simply says, you know what, if I've got a device over here and it's going to a server over here, I'll just give you one algorithm. I'm going to use the source and destination MAC address combination to choose which line it goes out. So let's just say we bundle those two lines together, right? This guy will always go out this line to reach that server. Now, what is the maximum speed he can get? Well, if all these are 1 gigabit per second line, maximum speed he can get is, drumroll, 1 gigabit per second. He will never see his file transfer faster than 1 gigabit per second, even though there are 2 lines here. So you might say, well, okay, why is EtherChannel an advantage to me then? Well, here is why. We've got another user here with a different source MAC address, maybe going to the same server, maybe going to a different server, whatever. The algorithm of EtherChannel will then choose, maybe let's just say this one. Now, it's not guaranteed that it's going to go on this. It's not like it watches like, well, I've got 5 users on that line and 2 users on that line, so I'm going to use that. I mean, no, it's just kind of like I'm putting this source and this destination together in this little hashing formula, and it's like, it spits out this answer, and that's the line you always use. So you hope, and the way the algorithm is written is that it's gonna get a 50-50 shot for the most part. So you're gonna hope that this guy goes this direction to reach the server, and this guy goes this direction. So that's where the advantage is. Breathe, Jeremy. Paper bag. So that's where the advantage is this guy gets his full 1 gigabit per second, whereas this guy gets his full 1 gigabit per second. Whereas if we were using spanning tree in the same situation here, both of them would share 1 gigabit per second. Let's just say they're sending full bore. The most they could get theoretically is 500 megabits per second, half of the gigabit per second, because both of them are sending and saturating that one line. Whereas now you can actually use both lines with EtherChannel. That's the beauty of EtherChannel. But wait, there's more. Take a look at my scenario number 2. EtherChannel, and I'll just say, just so you can see the terminology, a lot of other vendors call them lag, because EtherChannel is a Cisco word, and of course nobody wants to say, well, I'm Cisco. So lag is kind of an industry standard flavor. It's link aggregation is all it means. It's same thing, it's just the word, right? It does the same thing. So you can actually do this with servers as well. This is cool. So I can have, for instance, a really big server. Maybe there's a whole bunch of users accessing it. Maybe you've got VMware running on that guy, doing virtualization to where you've got actually 50 servers running on that one box or whatever. Maybe not that many. But the point is that, if that was just one network card, you would quickly saturate the line. You don't want this guy just sitting there idle waiting for something to die. So most servers nowadays can also support running an EtherChannel or a lag, or we'll look at PAGP, LACP, a lot of the protocols that are used to support this. But the point is, the functionality is there. You could take 8 lines to that one server. So now all of these users, all capable of running at 1 gigabit per second, don't saturate the line, one line going to that server. You can bundle them together and get more bandwidth. Now let's open up the hood and see how this guy works. EtherChannel is actually supported by one of, I guess I'll say 3 methods. How about that? 2 of them are protocols, PAGP and LACP. Okay, what's the deal? PAGP is Cisco proprietary, as in a Cisco way of negotiating between switches that allows them to say, okay, I want to bundle these. They communicate together and say, okay, you got that port, you got that. Okay, we're good. We're communicating. They're sending these little PAGP messages on here just to make sure everything is hunky-dory and we're all communicating on these ports. Now you can see that we've got 3 different modes of this: on, desirable, and auto. And this is why I want to go back to what I opened this slide with, which is you have 3 ways, 3 methods. On is actually not using PAGP at all, or LACP, the alternative to PAGP. Notice it also has an on method. Essentially all on does, let me clear this up, all on does is say, okay, I'm going to take these ports and they are in an EtherChannel bundle. Period. End of story. I'm now using these to bundle to the other side, and if we do on both sides, then he'll do the same thing, and life is good. Now, this is actually one of the areas where I would not suggest hard coding it. I know. I'm usually like auto, not do things. Anything you can hard code, you'll want to hard code, and that's true for the most part. But the reason I don't suggest, and Cisco doesn't suggest, hard coding the on, my hand went away, hard coding the on, is because when you hard code it on, if this side isn't configured correctly, you can't detect it. So if this guy's on, like, I am an EtherChannel, period, we're done. And this guy's like, maybe he's on this one, but somebody misconfigured this and this guy is off, or he's just a normal port. What you're going to do is create a black hole where this guy's just going to start load balancing and using that line, not even realizing that the other side isn't configured correctly. This side is dropping all the packets, so you end up with, half of your traffic going over this connection that ends up being dropped because it's going to the black hole of death over here on this side. So what the PAGP and LACP allow you to do is go in and set up a kind of like a hello, to where this guy's like, hello, just want to make sure you're still bundling, hello, make sure you're still bundling, and he does it the other way. So if this guy ever gets misconfigured and drops out, this guy immediately drops out of the EtherChannel as well, and now they just use that single connection. Or if you have 3 or 4 or 5 different lines going between the two, you'll do that. Oh, I just said 3 or 4 or 5 different lines. I also want to mention that EtherChannel is geared for powers of 2. So what that means is when you're bundling links, if you have 2 switches like this connected together, you want to make sure that you bundle them with 2 links, 4 links, or 8 links. It doesn't really do you any good if you put 5 links, 6 links in there, just because that's, again, this is all hardware based. There's chips on there that say how this works, and it uses powers of 2 to do the load balancing algorithm. So you're not really going to gain much benefit if you use 5. Essentially, if you use anything but a power of 2, you're not going to really gain too much benefit, because the load balancing algorithm does them in bundles, in these big bundles between the two. Okay, so that piece out of the way. What should I use? Should I use the industry standard or should I use PAGP? Whatever. There is no difference really between these protocols, other than one is Cisco proprietary and one is industry standard. And you might say, okay, well, I want to use the industry standard. Okay. I tip my hat to you. Go ahead and use the industry. And you go, well, I like Cisco. I want to do Cisco product. Okay, go ahead. It's not like you're going to be like, oh, one's better. The fact is, Cisco came out with this before it was out by an industry standard. Cisco was there. They were the pioneer in one of these features, so they created their own little Cisco proprietary protocol. Then the rest of the world is like, oh, Cisco's got a good idea. Let's catch up to them. And they all created LACP, which Cisco supports as well, and everybody agrees on it. But both of them are still around, both of them alive and well. Now, what about these? So these are the multiple modes that the PAGP and LACP can work in, right? So in a nutshell, it's aggressive and it's passive, right? So desirable is where this guy's saying, okay, I've configured this, for PAGP, and I'm gonna aggressively go out there and be like, I want to be an EtherChannel. Come on, who's coming with me? I want to be an EtherChannel. And this guy on the other side, as long as he's auto or desirable, he's also gonna be like, oh, I'm coming with you. Let's bundle our ports together and we'll join an EtherChannel, right? Auto is the passive version. So essentially, if this guy, let's say, is auto, he's ready to join. He's like, I'll come with anybody that joins an EtherChannel, but I'm not going to be, I don't want to offend anyone, right? I'm not going to step on anyone's toes and suggest that we should be an EtherChannel. I'll just sit here passively and wait for somebody to contact me, right? So the desirable side is going to be like, I want, and this guy's like, okay, I'll come along. So what does that mean? That means don't set both sides to auto. both sides to auto will not result in an ether channel. They'll just both stare at each other. They'll just be like, okay, you gonna make a move? I'm not. And so nobody makes a move. The best way per Cisco is to have one side desirable, one side auto. Why? Well, because if you have them both desirable, and now again, let me back up and say it's not going to break if you do both sides desirable. What will break is if you do both sides auto, as in it'll never happen, or I do one side desirable, one side on, or one side auto, one side on, because again, this isn't gonna. It's just gonna do it, right? It's not gonna try and negotiate with the other side. So anything that's matched to an on will not realize the other side is truly doing an ether channel. So by doing desirable and auto, you get this side suggesting, this guy agreeing, instead of having both sides desirable, where it's going to say, I want it, and they kind of do this little back off game. They're like, okay, we'll be there. It's not going to cause a problem if you have both sides desirable. And in fact, if you have that last brain cell that I'm filling up right now, you're like, I can't remember anything more. Just tell me both sides, then do both sides desirable. It'll work. It'll just take maybe a fraction of a second longer because they kind of have to back off and figure out who's gonna really start this ether channel negotiation. Same thing on LACP. They just have different modes: active, passive, instead of desirable and auto. I mean, I think the name of those are really a lot easier to understand. It's like aggressive and passive, that kind of thing. But also these names, you'll want to associate these with the protocol. Fact is, when you do this configuration, you never go in there. You can type the command, but it doesn't really do anything. You never go in there and say, I want to use PAGP. I want to use LACP. What you do instead is you type the mode you want. So if I type desirable, the switch then assumes, oh, they're using PAGP. If you type active, it goes, oh, you're using LACP. So obviously, incompatible would be a desirable and an active because you're using two totally different protocols. But this is what selects the protocol, not actually typing in the protocol name itself. Okay, let's get into the configuration. Like most things in the Cisco realm, the configuration of ether channel is very easy. It actually boils down to one command. It's just knowing the ramifications and all the scope around that one command that is the big deal. So what I've got, let me draw up my scenario. I actually have two switches here. We'll just call it switch 1 and switch 2. Simple actually no configuration other than a host name. I've connected ports 0/1 and 0/2 with crossover cables. So I would expect in the default state of things that spanning tree is going to jump in and get involved and block an interface. Let's check it out. I'm going to do a show spanning tree just to see the default state. Initially, I see, okay, root ID. Okay, down here, the ports. So I'm seeing fast Ethernet 0/1 and 0/2 are both forwarding. And you're going, loop. That's not good. Is this true? Is this right? Well, you have to step back and go, okay, well, wait a sec. This bridge is the root. Okay, so I happen to be on the root bridge right here. And remember, the root bridge never, ever blocks an interface. So let me do this. I'm going to come down here, switch my console cable on my switch down to switch 2. Let's try it again. I'll do a show spanning tree. And now we're looking better, right? So I see this bridge isn't the root, so this is switch 2. But look at fast Ethernet 0/2. That's what we would expect. We're going chunk, chunk, chunk. That port is blocked. Why? Because go back to the first slide. All things considered equal, the cost, the bridge ID, all that. It's the higher port number. So that one's being blocked. This one's being forwarding. So I'm wasting bandwidth. This is the perfect job for ether channel. Whoa! This just totally crossed my mind. Very common misconception that people have is when they start thinking about multiple switches like this. They go, okay, spanning tree is going to block this. Can I use like ether channel to somehow bundle that? Or no. Ether channel is only between directly connected switches. Hopefully that clarifies if you had that fuzzy question. So these guys can be an ether channel. This cannot, and this is probably going to end up getting blocked, especially if this is the root bridge, because that's how spanning tree rolls. It's going to block that port. So ether channel. So if I have two interfaces here, I can do ether. Now I can do this. Watch. I could have three switches like this. I could have chunk, 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 chunk. I could have an ether channel here and an ether channel here, like two ether channels on the same switch. That's totally cool. These would be considered two separate ether channels, though. It's not like I'm somehow magically bundling them all into one, right? Good with that? Okay. So we are not doing ether channel right now. So let's have some fun. I'm going to go in and do let's do interface range fast Ethernet 0/1 and 2. because I'm actually going to configure both of these at the same time with that mirrored config. Oh, I should start talking. Let me talk a little bit. Base interfaces have to have identical configuration when you're doing this. So they have to have the same speed, duplex. If you're doing trunking, access port or trunk port, what VLANs are assigned to the trunk. I mean, it has to be identical. This right here, ding, 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 bells going off. That's your number one troubleshooting issue right there. Is number one, you try to form the Ether channel and it's not working correctly. Where do you look? Interface configuration. Are they identical? I mean, like command by command has to be identical. And bing, 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 down the road, a year later, somebody's, let's say you've got a trunk here and you restricted the VLAN. They're like, okay, we got to add VLAN 5. So they come in, not even thinking about the Ether channel. They go into fast Ethernet 0/1 and do switch port trunk allowed VLAN. Add 5. So they add VLAN 5 as one of the allowed VLANs on that interface. Immediately, shoop, it drops out of the Ether channel. It's like, oh, sorry, that configuration is no longer synchronized, and you lose the Ether channel. It's not good. So number one troubleshooting step right there is make sure that they're mirrored. Then you can use the channel group command. This is what actually creates the Ether channel. Now, when you do that, all future configuration is done. I'm doing this. This is a big deal on the virtual port channel interface. So when you type this command, you're going to see this mystical new interface appear. That's going to be where you put all your future configurations. So that makes it easy. You want to adjust what VLAN. So this is this mystical interface that appears and inherits all of this configuration underneath there. So in the future, if you want to add VLANs, delete VLANs, change the mode, whatever, you go into the port channel and it automatically applies it to both of the physical interfaces. That's cool. So all configuration should be done there, and I'll show you the basic verification. So let's do this. Let's do a little config. I'll do speed 100, duplex full. I'm probably going to drop the interface. There you go, full. So just hard coding between them. Let's do switch port trunk encapsulation .1q. We'll change this guy into trunk. We'll do switch port. The switch is like up, down. You see why we should shut down interfaces before we do these kind of things. You're flapping interfaces right now. So switch port mode trunk. Make this a trunk port. And let's even. I'm thinking about how to break this. Let's do switch port trunk allowed VLAN. I'm going to allow VLANs 1 through 10. Let's just say I don't want to allow all of them, which is the default. I just want to allow 1 through 10. Let's check it out. Do show run interface fast Ethernet 0/1. Good. Hit the up arrow, just verify that I am doing this in the range. Good. Fast Ethernet 0/2 is there. Now, I'm actually, before I do this one Ether channel command, I'm going to come over here to switch 1, because it's not going to work if the other side isn't compatible. So let's do interface range fast Ethernet 0/1 through 2. And this is where copy and paste is awesome. Right click, bam. I just configured my interfaces. Good. So now they're going to go through their little flapping spaz mode. And actually, I'm just going to stay on here. I was going to move back to 2, but why not? Let's stay on 1. Check it out. I'm going to go into interface range fast Ethernet 0/1 through 2. And here's the 2 commands. It's kind of funny. Channel, I'll hit the question mark. You see channel group and channel protocol. Now, channel protocol will confuse the daylights out of you when you first look at it, because it says, okay, do you want to use LACP or PAGP? Now, I know some of you are like, well, that's not confusing. And well, others are remembering what I said. I said, you never actually type in the protocol. You never type it in there. You just choose what mode, desirable or auto or active or passive, and that actually chooses the mode. So, and let me show you this. So I'm going to do channel group. Let me show you this command. Channel just group. And we'll do 1. So this guy can have 64 Ether channels essentially on this. Now it may not support all 64. It's a hardware limitation, but these are the numbers. So this will be the number of the virtual interface. Remember I said this virtual port. It'll create one after this number. So let's use 10 just so we can see it. So I'll do channel group 10. Okay, more info on that. Channel group 10 we could say is going between these guys, right? So channel group 10. It does not have to match the other side. We could use channel group let's say 60 on this side. They don't have to match here. However, you got to be careful on the same switch. If I do another Ether channel like this, I can't use channel group 10 because otherwise it's going to get confused. It's going to go, wait a second, no. So I might do channel group 20 over here, or channel 11, whatever you want to do. So I'm going to do channel group 10, and then it's going to ask for the mode. Oop, and I'm going to mistype it. Mode, and the options are active. So this, notice, and thankfully context sensitive help gives it to you right here. Now, just to forewarn you on the exam, Cisco likes to do multiple choice questions like, what mode does this? You won't actually get the luxury of a question mark to fill that in, so you will have to remember that. So this chooses it. Now, so that then makes you go, well, if this chooses what protocol, why do we have a channel protocol command? That is a great question. I encourage you to Google it. Because everybody's asking the same question. And essentially the end of the game is people say, you know what, it's just kind of an FYI. Now, the question is, if you say channel protocol LACP, and then you go try and enable PAGP, will it work? Probably not. I haven't tried it because what insane person would do something like that? But the point is, channel protocol is optional. You don't have to use it. And everybody's wondering what that command is there for. Anyway, so let's use, what are we going to use? Let's use all in favor of PAGP. I am. So let's say channel group 10 mode desirable. Good. So look at creating a port channel interface, port channel 10. Just took the interface down. It's like, whoa, what just happened there? So it just went in there and created a port channel. So let's do a show IP interface brief. Now it brought the interfaces back up. We've got VLAN 1. Look at that. What's that? Port channel 10, the mystical ether channel that has been created. Now at this point, so PAGP is like, I desire the other side, and so it's sending out these little PAGP negotiation messages like, hey, can we be an ether channel? Switch to, please, can we be an ether channel? Switch 2 is like, that's exactly, it doesn't say anything. So switch 1 is keeping this port channel interface down, because the ether channel isn't working. So let's use this big show command at the end, right? You know, my best verification command. I love it. Show ether channel summary. And what do we have? We've got ether channel, or essentially port channel group 10. And I can see that I've got fast Ethernet 0/1 and 0/2 that are there. However, they're in this little I mode. What's I mode? Oh, I is standalone, meaning I'm not bundled. I want to see P's. I want to see P's bundled in the port channel, but I'm seeing I standalone. Like they're there, they're up, but they're not working in the ether channel. I can also see the protocol there. Pretty nice. So, port channel right here, SD, if you want to know what that means. It's a layer 2 ether channel. You can actually get into layer 3 switching and see a layer 3 ether channel where it's a routed interface, but you also see right here, D, it's down. But we're not good. So I'm going to happily move down to switch 2, happily, because I love seeing things work. Hit the enter key there. Okay, so let me get out of there. I am now, that's exactly where I wanted to be. Let's get back in there. All right, so I'm going to go into global config mode, interface range, fast Ethernet 0/1 through 2. And then, okay, so now I'm going to do the channel group. And we'll do, real normal people would use the same channel group on both sides because, let me just, I had an eraser. Oh, there we go. So real normal people would use channel group 10 on both sides because that's normal. That's what people do. But I just want to use a different number. Different number, because I want to prove to you that you don't have to use the same channel group number on both sides. So I'm on switch 2 now. I'm bundling fast Ethernet 0/1. I'll use channel group 5, right? Now, what is my mode? Well, again, we could use desirable. It would work. It would just take, you'd see if you were debugging it and watching what's happening, you'd see a few more messages that aren't necessary. Let's go auto. It's like positive, negative, a battery matching up. It's good. So one side is aggressive. That's the desirable. And then you have the passive auto, just waiting for somebody to contact them. So we'll type in channel group 5 mode auto, right? We'll give it a second. Change to down. Our interface is now down. I'm holding my breath. Let's do a show IP interface brief. It is still, they're coming up. Did you see that message? Let me highlight it right there. Oh, that's so good. Port channel 5, change state to up, change state to up. So now as I scroll down, let's do include port. So port channel 5 right there. Is there. It's up. It's up. We've got now, they're just doing their final negotiation. Let's just do a quick show run. Show run interface, port channel 5. Look at that. So this mystical make-believe interface has inherited most of the configuration that's on the physical interfaces. Now, what's missing? Speed and duplex. Now, that's a physical interface command. This is a logical interface, so it's not inheriting speed and duplex, but it is inheriting all the logical configuration. So now, moving forward, all your configuration should be done from here. So let's just verify. Hang on, let's do it from here. Show EtherChannel summary. Hit the enter key. Yum. Where did that come from? So, port channel 5, S, layer 2, it's up. U obviously means in use. It's up. It's running. Look at the interfaces over here. Fast Ethernet 0/1. P, we are in the port channel. We're there. Now, just for grins, I know you're probably like, it's going to work. It's going to work. But I want to see it. I'm going to come over here back to switch 1 and hit the up arrow and do that same command. The same command that was broken before is now reporting success. Port channel 10 over on switch 1 is now up. And both of these are bundled in the port channel. So good. I'm going to go into, let's break it. Fast Ethernet 0/1. And I'm going to, let's just do something silly. I'm going to do a switch port, trunk, allowed VLAN, and this is what I was talking about earlier. Somebody could so easily do this. Allowed VLAN, and we'll just say add, let's just say 12, right? So I'm going to add VLAN 12 to Fast Ethernet 0/1. Bam! Immediately, it's like, cannot bundle Fast Ethernet 0/1. Not compatible. Will be suspended. VLAN mask is different. Look at that. Change state to down. You're dead. I mean, that's it. So when I go back and I look at the EtherChannel summary, now, if this is a production network where there's a lot of traffic going across, now everything just jumped over to Fast Ethernet 0/2, which is now bogged down. Things are slow and packets are dropping and not very good. So hopefully it's not that bad. But notice Fast Ethernet 0/1 is suspended. This little S, where S, somewhere up there that I can't, right there, suspended, because its configuration doesn't match. So now, show run interface. It'll fix itself. Don't worry. If you go in there and go interface Fast Ethernet 0/1 and do switch port, trunk, allowed, VLAN, let's do a remove 12. Get that guy out of there. And now, he's going to come back and change state to up. You'll see him return himself to the, it's like, come home, Fast Ethernet 0/1. Everybody will accept him. So interface, port channel, let's do port dash channel 10, because I'm crazy, right? 10 on this switch, right? So this is where I would want to go in and make that change. So I would do anyway, you get the idea. This is where I would add in my switch port, trunk, allowed, VLAN, such and such. But now I can go back and do a show EtherChannel summary. And as long as those guys are compatible, he will return to the bundle and be welcomed home. EtherChannel is so fun. So let's wrap up. We have seen why block when you can bundle. I mean, again, why block via spanning tree when you have multiple redundant connections on the switch. And the good thing about this is that these connections are very inexpensive. I mean, most of the time these switches are sitting right next to each other. So you can just take a bunch of fiber patch cables. You can take a bunch of Ethernet patch cords. Very inexpensive and increase the bandwidth between those. That's why when you see the best practice design from Cisco, you see the access layer down here, right? All these access layer switches that are going to the distribution layer switches. I can't. And then what do you see right here? Always, you see this in the network diagrams that you see, because those distribution layer switches are commonly just sitting right next to each other in the same MDF closet or something, and so it's very easy to bring up a massive bundle. So when people are communicating, there's never a bottleneck right there. PACP, LACP, Cisco proprietary, industry standard. Use whatever you like. They do the same thing. EtherChannel configuration verification is where we spent most of our time looking at those commands. I hope this has been informative for you, and I'd like to thank you for viewing.